So good afternoon, students, and welcome to this session. Next class, that is insertion sort. Till now, what we have seen in the class is there is a function like this. This is called f of n, and this one is time, and this one is n number of elements. Till now, we have seen that, and this f of n is called time taken by an algorithm. Okay, but actually, it is not the exact time taken by algorithm. It is the number of iterations actually, or we can say it is the approximation time taken by an algorithm. It is a approximation time. So we'll see how to find an approximate time taken by algorithm. So there are two types of algorithms actually. There are two types of algorithms that are available. First one is, there are two types of algorithms, and first one is the iterative one, and second one is the recursive one. So there are two types of algorithm, iterative and recursive one. Okay, so iterative one will look like this. If there is a function a, or this is a program, then there will be a some kind of loop in it from 0 to n, and it may call some other function. Okay, so this is the example of iterative program. This one is the example of iterative function. And what is the example of recursive function? So if function calls itself again inside the function, then it is called a recursive function. There may be some if condition that will get us out of that recursive calls, or this this is called iterative function, because this function is being called in the function again. Okay, so uh, calling function inside a function is called calling function inside a function is called recursive algorithm. So this one is iterative algorithm, and this one is recursive algorithm. So first I would like to say these are equal in power. Why equal in power? Any problem that can be solved using iterative method can also be solved using recursive method. Okay, so both are equal in power. Any program that can be written in iterative way can also be written in recursive way. Both are equal in power. Okay, so these are two types of algorithms. So to analyze this one, this iterative algorithm, there are the analysis is how to find its time complexity and space complexity. So to analyze this one, iterative program, we can count number of times loop is executing. Number of time loop is executing. So this is how we calculate the time of iterative, or how we do the analysis of iterative algorithm. Then how do we do the analysis of recursive algorithm? So to analyze the recursive program, we use recursive equations. Okay, so we will see the examples of these both. First, how do we analyze this? Then we will come back to the insertion sort. So we'll see some examples. Like there is some example. If this is the function and we need to find its complexity, the time complexity I'm talking about. So we'll write for I equals to this algorithm is not in any language. So this is just a algorithm, just some steps. So this is not any the syntax is not does not belong to any particular language, but this is just an blueprint or pseudo code actually. So this is an algorithm. So let's say this is our algorithm, and inside this I have written printf, and how do we analyze this one? How do we do the analysis? So I have told you to analyze this. This is a iterative function. To analyze the iterative function, we used to count number of time loop is getting executed. So how many time loop is getting executed? This is n time, and to assign a variable to one, it will take some constant time. Let's say c, and anything inside the loop will how many times it will get executed, that will be n minus 1, and to print something, uh, it will take c time, some constant time, that will, I'll tell you later in the last of this lecture. Now we can add all these values. This is n, and this is n, and what is inside this loop? So this loop is executing n times, so this will be n, and the part that is inside that loop will get executed n minus 1 time. Why? So this is c plus n minus 1. So if I'll count this one, this will become 2n, and constants, all the constants in the equation can be ignored. So its worst case complexity will be big O of n. This will be big O of n because this is the biggest term in the whole equation. So that I've told you in the previous class, we need to consider the biggest term out of this whole equation. Why? But why here we have written n minus 1? Because if any particular loop, if any particular loop will execute, let's say this loop will execute 5 times, the inner part will get executed 4 times, because for the 5th time it will again check for the condition that we have mentioned in it. For the 5th time it will check for the condition that we have mentioned in it. Like if I have written I is less than 5, less than 4, so I've written I plus plus, and if I want to print the value of I, it will get printed, like this. I will be 0, then 1, then 2, then 3, and then that's it. 4 time it will get executed. So 4 time we have this value, but for 5th time it will again check the condition. So if this is executing, if this one is executing n times, the inner part of for loop will get executed 4 times, n minus 1 times. So we'll see one more example here for the same iterative function. So that was being asked, that was the question of some previous gate question, so that we'll discuss. So this is the program. Let's say this is the algorithm. If I equals to 1 and s equals to 1, and while loop is there, and it is executing less than equals to n times, and I is incremented by 1, and then s is incremented by I, and then we use printf, any other any printing statement, let's say agc, and then we have stopped this loop, and then we have closed this compound statement. So this is the compound statement belongs to while loop. This one, this compound statement belongs to the whole algorithm. Okay, so how do we analyze this one? How do we analyze this one? So we need to check all the values of s and I. So uh, let's say this is our program, and we want to analyze what will be the value of s and what will be the value of s. So we need to find out when this loop will end. So this loop will end when s will become equals to n, or it is till it is less than or equals to n, this loop will get executed, and if it is greater than n, then it will not get executed, that then it will get exit from this while loop. Okay, so what will be the value of s here? So s is 1 and I is 1 in the beginning. So I'll write here s equals to 1 and I equals to 1. And after that, what will be the value of, because it will check n is some value, n is some random value. Let's say it's k. So it will get executed till k. It could be 5, it could be 10, or it could be anything given by user. So we don't know yet what is the value of n. And still we want to find out uh, what is the complexity of this program. So we still want to find this out. So if s equals to 1 and I equals to 1, s is also equals to 1, when I will become 2, so s is s plus I. So what is s? 1. 1 plus 2. 1 plus 2 will be 3 here. Okay, then what will be the next term? Next value of I will be 3. And what is the value of s here? S plus I is 3 plus 3, that is 6. Okay, then i's value will become 4, because I is getting incremented by 1. I is getting incremented by 1, and s is getting incremented by I. So whatever the value of I will be there, that will get added in the value of previous value of s. Like this, here we have 4 and here we have 6. 6 plus 4 will be 10. And then if i's value will become 5, value of s will become 15. 10 plus 5 will be 15. Now it will get, how much time, uh, how many time will it get executed? So it will get executed till we have the value of n. And let's say this is a continuous sequence of numbers, and it will get executed till k, till n, and till k. Okay, so if we can see what will be the value of n, we can find out the value of n from here. So what is this number? This is sum of these two numbers. What is this number? This is sum of these two numbers. You can check it. Oh, 2 plus 1 is 3, 3 plus 3 is 6. So what is this number? This one, s. That is sum of all these three numbers. What is this number? This is sum of all these 5 numbers. And what will be the end? In end, we will have sum of all these numbers. So sum of all natural numbers starting from 1, sum of all natural numbers till k. So how do we find out the sum of all natural numbers? That is done by number of terms divided by 2, and first term, that is 1, plus last term, that is k. So this whole term should be greater than n, should be greater than n. Then only this loop will get stopped, and this will be the worst case. So what will be the worst case in this case? So we know if we multiply this, all other constants can be ignored. K square will be the value, and it should be greater than n, and order of k, yeah, big of k will become under root of n. We'll transfer this power to this side, and this will become under root of n. So this will be the complexity of this program that was asked in gate paper, that is graduate aptitude test for engineering. So I hope it is clear. Now we have seen examples of iterative algorithm. Now we will see example of recursive algorithm. There are two types of algorithms again, iterative one and recursive one. So we have seen the examples of iterative function. Now we will see the examples of recursive function. Let's say this one is our function, and So we can form a recursive equation out of this algorithm. How can we form a recursive equation? This is a journal example. If this in this we have n input, if in this we have n input, now we are dividing this whole function into n by 2 and n by 2 lists, like we did in binary search. In binary search, the algorithm, the list of elements, list of array, or elements of array are divided into two parts, left subpart and right subpart. So that will get divided into two equal halves, n by 2 and n by 2. How can we find the equation in it? Let's say this if condition will take some constant time. So we'll see the total time taken by this function Tn will be equals to C plus 2 times time of n by 2. If a problem gets solved in whole time is Tn, half of the problem will get solved in Tn by 2. Okay, and there are two halves, so this will be equals to this, some constant time plus some time taken by this function, this recursive call, that will be 2t n by 2. So this is how we find out the recursive equation. Now we will find out the complexity of some program, some other program, or the other example. So let's say this is our example, and there is some exit condition for recursion, and we are returning n minus 1. This recursion will only stop when this condition will get false. Otherwise, it will keep on calling this function again and again and again. Okay, this will be a kind of some infinite loop. Okay, so there is this multiple recursive calls until we met this condition, that is n greater than 1. If n will become equals to 1, this recursion will get stopped here. Okay, this recursion will have to stop there. So this is our function. Now we'll find out its recursive equation. So if total time taken by this whole function is Tn, so it will be some constant time taken by this function plus t of n minus 1. So if this whole function take n times, this function call will take t of n minus 1 time, because this is being called n minus 1 time. So how to solve this function? Now there is a method called, there are many different methods, there are 3 different methods. We'll discuss all these in coming lectures. So this one is our back substitution method that we are going to use today for this example. So I'll write it again. What is our recursive equation and how can we solve it to find out the time complexity? That is C plus T of n minus 1. This is our recursive equation. We will use back substitution method. What is that? Let's see. So if this is the time, and what will be the time of Tn, what will be Tn minus 1? So I can say if I'll put n minus 1 here, then I can get the time in this equation, n minus 1. So if I'll put n minus 1 here, I'll get n minus 1 minus 1. So instead of n, I have written n minus 1. Instead of n, I have written n minus 1. So I can say t of n minus 1 will be C plus t of n minus 2. So let's say this is equation 1 and this one is equation 2. Okay, if I want to find out the value of Tn minus 2. So here in the first equation, I will put, instead of n, I will put n minus 2. I will write here n minus 2. So it will be C of T of n minus 2 minus 1. And that will become T of n minus 3. Okay. And if I put the answer of this equation in first equation again, back substitution. If I'll put this again, what will happen then? I'm going to write at this side. Okay. So I'll put the value of 2 in 1. Now you can write it down. Put the value of 2 in 1. So I'm going to do the back substitution here. So what will be the value of t n minus 1? That is c plus t of n minus 2. So here, instead of writing this, I am writing this. Okay. So what will be the value here? It will be like and it will be like this, c plus c, and this will be t of n minus 2. Okay, instead of n minus 1, I have written c plus tn minus 2. So after writing it, I can write like this, 2c plus t of n minus 2. I have already told you we need to ignore all the constants. So I will write here 2 of 2 plus n minus 2. Instead of this equation, tn minus 2, we have this value. We'll put this value in place of this thing, tn minus 2. What is the value of tn minus 2? That is c plus t of n minus 3. This one, c plus t of n minus 3. So instead of tn minus 2, I have written this, c plus t of n minus 3. So that will become 3c, 3. Let's say it will become 3 of n minus 3. Okay. So here we cannot stop. As we know, the equations are becoming like this. Equations are becoming like this. Now our last equation was this. Our last equation was, let's say tn was 2 plus t of n minus 2, and after that, if I write t of n minus 3 here, okay, and if I keep on going and substitute this, let's say it will go to k, and it will be t of n minus k. Okay, because 3 plus t of n minus 3, 2 plus t of n minus 2 is there. Here we will have, uh, if you want to write c here, you can write it. That will not make any difference. Okay, that will not make any difference. You can write it there. But what will be the value here? In the last term will be k of k plus t of n minus 3. Then what? When will it stop? So we have seen in the algorithm, it will only stop when n is greater than equals to greater than uh, when n is less equals to 1. So if this whole term, this whole time will become equals to 1, then only it will stop. So what will be the value of n in this case, or what will be the value of k in this case? So k will be equals to n minus 1 here. So this term only will stop. This is the ending term, last term. Last term only will stop if this whole term, whole time taken will become equals to 1. So that's why I've written n1 equals to n1 minus k equals to 1. Here we have the value of k, that is n minus 1. Now we can substitute the value of k. So k will become n minus 1 plus uh, here we will have the value of k, that will be n minus plus 1. So Tn is time taken will become 1 only, because n and n will get cancelled here. And so this will be 1 time, that is constant time, and n minus 1 time. So out of these all terms, n is the greatest term. So n will be the complexity. N will be the complexity of this recursive function. So now we will see the algorithm of insertion sort, and let me tell you that the insertion sort is always good for small inputs, even better than quick sort. So insertion sort is better than quick sort for small inputs. If there are large number of inputs, then we have to compare their complexities. First, we will see what is the algorithm of insertion sort. And how do we write the algorithm? So first we have to write the name of the algorithm, that is insertion sort. Always write name of the algorithm. That is the first rule to write algorithm. And we'll pass the arguments, that is how many number of elements are there in array. We have passed the array A here. Okay, this is insertion sort. Now we'll start it with the for loop. So this is not in any language, any particular language. This is just a program, a pseudo code that can be converted into any other language. You can use any language like C, C++, Java, or Python. So for J2, length of A it will run, and in next step in this loop we'll write key element equals to A of J. What are these? I'll explain you one by one. Okay, and then we'll write I equals to J minus 1, and we'll take one more loop inside it, while loop, and it should be I should be greater than 0, and there is a condition in it, A of I should be greater than key to enter in this loop. These two conditions should be must to enter in this while loop. So after entering in it, what we need to do here, we'll exchange the values A of I plus 1 with A of I if this is true, and then I equals to I minus 1, and out of these will come out of this loop, and we will write A of I plus 1 equals to key element, key element, and uh, here we will stop for loop, and here it is the end of this algorithm. So this is very simple algorithm. I hope you can see it. Okay, now let's see its example and run this algorithm one while seeing this example. Okay, let's see, this one is the example. Here we have elements like 9, we have elements like 9, 6, 5, 0, 8, 2, 7. We'll write like this. Let's see, it's not on the board. 9, 6, 5, and 0, 8, 2, 7. Okay, these are the elements. Let's say one more element, 1. Okay, so let me tell you how to run this algorithm on this example. Okay, so as you can see from the board, this is our algorithm. So what is insertion sort again? Let's take an example. Let's say that you have a deck of cards that are uh, placed on a table in this way, in a reverse way. The face of card is facing downward uh, towards the table. So this is a deck of cards, whole deck of cards like this on the table. So we have placed deck of card on table facing downwards. Now we will take the first card out of this deck in our other hand, and will not compare it with any other element. So first element is always sorted. First element is always sorted. Like in this case, first element is always sorted. So we need not to compare it with any other element. So that's why we have started the loop from 2. For j equals to 2 to the length of array. Okay, in this case the length is, this is the length of array. Okay, so we'll take the second card then and check it with the first card, firstly drawn card. Already we have drawn a card, and we'll place it according to its position. If it is smaller than this card, it will be placed on the left side, and if it is greater than this card, it will be placed on the right side. So we'll compare it with the second element. So that's why we have taken the key element A of j. What is A of j? J's value is 2. In this case, A of j that is its value is 2 if we start it from 1. So let us start it from 1. So length is 8 in this case. Length is 8 in this case, and we'll start from 2. So a of 2, what is a of 2? This is a, this is whole array, this whole array is a, this one is a, and what is a of 2? That is 6. So key's value will become 6 here. The value of key is 6. Okay, a of 2 is 6. Now we will compare it. We will also take I. What is I? Here we have written j equals to 2. So this is j, this one is j. Let me write it clearly. This one is j, and what will be the value of I? I is the previous element, because I equals to j minus 1. If j is 2, if j is 2, I will be 2 minus 1. Okay, so this is I. Now what is the value of key? A of j. A of j is 6. So this is the key element. Let's say key equals to 6, and key equals to 6. And now what is the next step? This loop will get executed. Is the value of I 0? No, it is greater than 0. So this loop, this is okay. Both these conditions have to be true to get entered in this loop. Both these conditions have to be true. If any one of them is false, we will not enter, the control will not enter in this loop. Okay, so as we have seen, first in the first step, value of key is 6. Now I is greater than 0. We can see value of I is 1 and it is greater than 0. Then we need to check the second condition. The second condition is a of I, that is a of 1 in this case, that is 9. So 9 should be here. I'm going to write it here. 9 is greater than key. Is it true? Yes, both conditions are true. Here we have value of I equals to 1. So both conditions are true. If this both conditions are true, then we have to replace it. If this element is bigger than the key element, we have to replace it. Instead of I plus 1, we need to write a of I. So instead of this I plus 1, that is 2. I plus 1 is 2. So at 2, we will write 9. Okay. Then what is the next step? Next step is subtract the value of I by 1. So reduce the value by 1. So if the value of I was 1, now it will become 0. I's value will become 0. And this loop will get again executed, because here we have end of this loop. So again it will check for the values. Now the i's value is 0. So this condition, the first condition is false. It will not enter in this loop. And the next step is at I plus 1 we will place the key element. At I plus 1 we will place the key element. As we have seen, value of I is 0. So 0 plus 1 is 1. So at 1 we will place the key value. What is the value of key element? That is 6. So here we'll place 6. Now we can see both these elements are sorted, not the rest of the elements. But again this for loop will run. Now it will run for j equals to 3. Now j's value is 3. What will be the value of key? That will be the element under this. That is 5. Okay. Now what will be the value of I? I we can see next step and next step. Next step is I equals to j minus 1. So j is 3 and I will be 2. Okay. And in next step is in while loop, it will check i's value is greater than 0. That is greater than 0 because I is 2. So I is greater than 2. That is true. And second condition is a of I. A of I is 9. That is a of I, that is 9. Is it greater than 5? So both the conditions are true. So it will enter in the loop. At I plus 1, because I is 2. At 2 plus 1, that is 3. Here we will place a of I, that is 9. So we'll place 9 here. And After that, next step is I minus 1. Now i's value will become 1. And this while loop executes again. Now value of I is 1. That is still greater than 0. I equals to 1. That is greater than 0. That is true. Then check for the next condition. That is A of I. That is 6 is greater than 5. It is not true. So we will not enter this loop in this loop again. The control will not get entered in this loop. What is the next step then? At I plus 1, we will place key. At I plus 1, we will place key. What is I plus 1? I is 1. 1 plus 1, we will place key. That is 5. 6, sorry, 6 is greater than 5. So this condition is true. At I plus 1, we will place I. So I is 1. At this place, we will place A of I, that is 6. 6 will get copied here. And we will reduce value of I by 1. Now a value of I was 1 and it will become 0. If it will become 0, this loop will not get executed. And at 0 plus 1, we will place 5. So we can see these three elements are sorted. Actually, this is how insertion sort is done. First, we will have a list of sorted elements and list of unsorted elements, and we'll find the position of this unsorted element in this sorted list. We'll find the position of this unsorted element in this sorted list. Okay, this is how we do the insertion sort. I'll do it uh, to the next elements. We can see next step will be j equals to 4. The previous step, the current step, j equals to 4, and in the next step we'll have j equals to 5 and I will be 4. So the element at this one will be assigned, at j will be assigned a key element. 8 is the key element now. 8 is the key element, and we will compare it with the previous element. So we'll compare it with the previous element here. So we can see previous element is 9. 9 is greater than 8. 9 is greater than 8. That is true. So we'll shift it to the next point. So we'll write 9 here and reduce i's value by 1. So I will become 3 here. Now we'll compare it with the key element again. 8. 8 is not less than 6. So this condition is false this time. 8 is not less than, this condition is not true. So at the position, we are at third position. So at 3 plus 1, we will place our key element, that is 8. So we have sorted like this. All the elements will get sorted by using this insertion sort algorithm. So let's see the complexities then of this algorithm. Okay, so what will be the example of worst case? There are two ways to find out the complexities again uh, for any algorithm. That first one is the easy way, other one is a difficult way. Not difficult actually, it is a numerical way. It is how we do it properly on the exam. And I'll tell you the simple way first, and then we will do the next way. So our problem is to sort elements. If the problem is to sort elements in ascending order like this is our problem. And if we get the input by user not like this but like this, so if this is our input, so this is if we want to sort the element in ascending order, but the elements are already sorted in descending order. That is the worst case in case of insertion sort. In case of insertion sort, worst case. Now we will check. We'll start from this one, yes, from second element, because first element is already sorted. So in this case, if I write for j equals to 2, for j equals to 2, for j equals to 2, how many comparisons will be there and how many movement will be there. There will be comparisons and there will be movements. So what is the meaning of comparison? We are comparing this element with some other element. That is comparison. And after comparing, we'll exchange the values. That is called movements. So if I'll compare this one, there will be how many comparisons? One comparison for j equals to 2 and one movement. Okay, that will become total two things. Okay, then for j equals to 3, we'll have to compare it with this one and this one also. So there will be two comparisons and two movements. That will be 4. And for j equals to 4, there will be 3 comparisons. We'll compare it with all the elements because this element is smaller than all the elements. So this doesn't mean that we'll find the element in between. We'll have to go all we have to compare it with all the elements. So for j equals to 4, there will be 3 comparisons and 3 movements. We'll copy this one here, we'll copy this one here, this copy this, compare it with this one, compare it with this one, compare this with this one. So we'll compare it with all the elements, but and it will become 6 for j equals to 5. And if there are n elements, for n elements, it will compare n minus 1 plus n minus 1 movements, n minus 1 comparisons and n minus 1 movements will be there. Okay, so if I write this term as 2 of n minus 1, I'll write this term as 2 n minus 1. And can I write this one also 2 n minus 1? And if I write this also like this one 2 of 2 minus 1, can I write this one like this? 2 of that is what? 2 of 2, that is 4, है ना? 2 of 3 minus 1, n is 3 in this case, है ना? j equals to 2, j equals to 3, j equals to 4. So n is 4 in this case. So I'll write it 2 of n minus 1, that is 4 minus 1, 3. Is it okay? Now if I write this n times, so this will become 2 plus this up to 2 of n minus 1, 2 of n minus 1. This will become like this again. Let me write it again. If I'll take 2 common, this is the worst case, mind it, this is the worst case. If I'll take 2 common, this will become 1 plus 2 plus 3 up to how many comparisons actually? That is n, this many comparisons. And if I'll write the formula of sum of n natural numbers, that will be n into n plus 1 actually, but the first term is last term is number of element is n minus 1, and n minus 1 last term plus first term is 1. So this is number of elements n minus 1 and last term plus first term. So if I'll cancel this plus 1 and minus 1, this will become n square minus n divided by 2. So this is our polynomial equation in this case, that is n square minus n. Which one is bigger out of these two? So we'll consider that bigger one, our worst case time complexity. This is our worst case time complexity, that is big O of n square. Big O of n square is our time complexity. Okay, then let's see the Worst case, we have seen the worst case, we'll see the best case. What is the best case of insertion sort? If we are doing sorting and we are doing it in the ascending order, if elements are already sorted, so that will be the best case. If elements are already sorted. And how many comparisons for j equals to 2 I have to done? What will be the number of comparisons and number of movements I'll have to do? So I'll have to compare one element, only one element. Okay. So one comparison for j equals to 1. Then one comparison will be done here, one here, one here, one here, one here. If there are n elements, so n minus 1 comparisons will be there. So this is our equation, n minus 1. So out of this n minus 1, if we have 10 lakh elements, we'll subtract 1, it will hardly make any difference. So that's why we are ignoring constants. So complexity will be order of n. So we have this complexity big O of n, big O of n. So this is the best case, and the average case is nearly equals to the worst case, always nearly equals to the worst case, because some of the elements will be sorted and some will not be sorted. And if we calculate the time, it will come in the polynomial time, that is n square minus n. So that is how we find out the complexity of this insertion sort. So if we want to do it numerically, how can we do that? Let's say all these assignment, there are assignment operators as well. We have equals to sign here, 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 equals to sign. It will take some time to assign the value. We will consider that time as a constant time. So we'll write it, all these lines will take some constant time. So I'll write different constants like c1, c2, c3. C1 time taken by this line, c2 by this line, then c4, c5, c6, and c7. That's it. This is the constant time taken by each step. Constant time taken by at each step. Now what will, how many times this loop will get executed? If there are n elements, this will get executed n times. Okay, n times, and its inner part will get executed n minus 1 time, and this is also inner part of this for loop. This will also get executed n minus 1 times. This one is also part of this for loop, so we'll write here n minus 1 time. What about this one? What about this one? So let's say it will take t time to get executed, and there will be different values of t starting from j to n. We'll sum all the values. Okay, summation of j equals to 2 to n, and t time will be taken by this loop. Any time will be taken by this loop, but if the number of elements are n and it is starting from 2, so it will take it will execute this many times. Okay, and if this loop runs this many times, inner part of this loop, these 2 points will get executed same number of time minus 1, same number of time minus 1. Now we will add all these terms, add and multiply. This is constant time taken by this, constant time taken by this. So we will add and multiply these terms. We will add and multiply these terms. So what do we write here? C1 into n minus 1. Okay, the first constant and the first time taken. Then we will write, if we have written n time, c1 will take n time, so we will write c1 into n plus second was c2 into n minus 1 plus c3 into n minus 1 plus next time was C4 C4 into summation of from J2 to N T of J. T of J, T time will be taken, and then C5 is summation of 2 to N T of J. This much time will be taken by inner path -1. Okay, -1 plus C6 is there, plus C6 is there, and at C6 also we have written, if you have noted it down, then it will be J of 2 to N T of J -1. That is inner part of this while loop. Inner part of this while loop. We multiplied with the constant time taken at each step. Then we will write in the next step again last point, that is C7. C7 was part of this for loop. So if for loop taking n time, this will take n-1 time. So multiplied by some constant C7. Now we need to solve this equation to find out our big O of, to find out our time. Tn equals to this. This is our time. This is our equation. So how can we solve this? Let's do the best case first. What will be the best case? So this C4 is nothing but this step, because we have written C1, C2, C3 and C4 here. This step. How many? This is nothing but how many times we will compare. How many comparisons will be there? How many comparisons will be there? If this is the best case, there will be only comparisons. There will be only comparisons, but this inner part will not get executed, because this is the best case. This inner part is for movements. This inner part is for movements. There will be no movements, only comparisons. How many comparisons actually? N-1 comparison. So these two parts, inner parts C5 and C6 will be 0 in this case. This will be 0. If these are 0, all other elements will be there, but these two elements will not be there. But how much time will this loop take? This loop will take n-1 time, that we have just seen. This will get executed n- time. Compare how many comparisons will be there. We'll compare it with this. There will be one comparison, then second, then third, then fourth, and then fifth. If there are 6 elements, there will be 5 comparisons. If there are n elements, there will be n-1 comparisons. Now I'll solve this one, this equation. Okay. In order to solve it, I'll separate all the terms with n-1 and all the terms with n-1 will be separated. So if I'll solve this, this will become like this: C1 plus C2 plus C3 plus C4 plus C7 into n minus C2 plus C3 plus C4 plus C7. Okay, this will become the term, and if I'll assign a bigger constant to all these constants, this will become a of n, one constant to all these constants, a of n minus b. So this is our time. So because this is the bigger term, we can say this is the omega of n, best case, omega of n. Okay. Now we'll see the best case. Sorry, the worst case. We have already seen the best case. Now what is the worst case? Same equation will be there, because this much time will be taken, but the elements are reversed. And now we can see there will be many comparisons and there will be as many as movements there. So we'll need to write the values of these three equations: C5, C4, C6. All other we already know that C7 is n-1 and C1 is n. So we need to find out the value of these terms. So what will be the value of these terms? We already know these all loops, these all points will executed in terms of n square minus 1 by 2, 2 into n, so like this. So this will be the same value, this will also be same value, this will also become the same value, but minus 1 will be there, only minus 1 will be there. So this many times, this many comparisons and this many movements will be there. So this many comparisons and this many movements will be there, we have already seen. So if I'll write it in the short form, so I have to write like this will be like C4 by 2 plus C5 by 2. After solving it, I'll write like this, C6 by 2, and this is our whole time Tn by 2 into n square plus C1 plus C2 plus C3 plus C4 plus minus C5 minus C6 plus C7 into n, and there will be one more term without n because minus 1 will be there. So it is like, it will be like this, um, minus C2 plus C4 plus C5 plus C8. So this is a constant, this is one is also constant. If all these are constant, I can also write this A into n square plus B into n minus all these constants C, A, B, C. Okay. So time taken by this whole algorithm will be a n square b n minus c. This is the f of n actually that we have talked about in the previous lecture in asymptotic notations. This is the function of rate of growth of time. So time will grow like this, a of n square plus b of n minus c. So n square will be the worst case. N square belongs to the worst case that we have find out in the asymptotic notation. So answer will be like O of n square, because this is the biggest term in this equation, order of n square, and this one is the biggest in terms of power. So n square is the biggest in power. So this is how we do the analysis. Now one last thing. We can make this algorithm, we can reduce the number of comparisons, but we cannot reduce the complexity. This is the best uh, algorithm. As we know, at the left side, the elements are already sorted. So instead of searching it sequentially, we search it one by one and place the element here. We can use binary search here. But the number of movements will remain same, or we'll have to do the same number of movements and multiply with this term. In binary search, the time taken is log n. So we can reduce the number of comparisons, but we cannot reduce the whole complexity at this time. So this is the best algorithm for insertion sort that have a complexity of worst case n square. So that will be all for today. Thank you.